In this video, we're going to talk about interval notation. So we got all real numbers that's greater than -8 and less than or equal to 20. So we could use interval notation. So parentheses, -8, comma, 20, bracket. So this is the same thing as this expression right here. Since 20 is included, we're going to use bracket. -8 is not included, so we use parentheses. What about x greater than 12? That means all real numbers that are greater than 12. Well, 12 is the smallest number, and 12 is not included. So parentheses, comma. Now it's all real numbers that are greater than 12. So we have this symbol called infinity. And you cannot contain the infinity, so it's parentheses. What about this one? All real numbers that are less than or equal to -8, or all real numbers that are greater than 5. Well, all real numbers that are less than -8, and notice it's included, so -8, you put bracket, and it's all real numbers that are less than or equal to -8, so it's parentheses, negative infinity. It says or, so we're going to use this symbol. It's a union symbol. And now this time you have x is greater than 5. And 5 is not included, so parentheses, 5, comma, infinity. Let's do some more examples here. How would you use interval notation here? It's all real numbers that are greater than or equal to -4 and less than -1. So we use this bracket on -4, comma, and it goes all the way up to -1. But -1 is not included, so we use parentheses. What about this one? All real numbers that are greater than or equal to -3. Well, bracket on -3, and it goes all the way up, so it'll be infinity. Remember, you cannot contain infinity or negative infinity. And what about this one? X is greater than 9, so 9, comma, infinity, or, so union, x is less than -2. So -2, and it has to be negative infinity. Negative infinity, comma, -2. And we're going to talk about function. Okay, how do you know that something is a function? Well, there's this thing called vertical line test. You draw a vertical line, and at most, you intercept at one point, then it's a function. So this graph right here is a function because at most, it intercept is only at one point. If it intercepts more than one point, then it's not a function. So for example, this graph right here cannot be a function because when you do a vertical line test, you intercept more than one point. Now, is this table a function? Well, you could plot them and see if it passes a vertical line test. But as you can see, notice, you got 3, -1, and 3, 4. And this is not a function, because if you plot it, it will not pass the vertical line test. What about y squared minus 2x equals 5? Well, let's solve for y and see what happens. We got y squared equals 2x plus 5. And y is going to be positive negative square root of 2x plus 5. And this is not a function because let's say, for example, when x equals 1, when x equals 1, you are going to get two y values. You are going to get positive, negative, radical 7. So you're getting 1 comma radical 7 and 1 comma negative radical 7. And this is not a function because it will not pass the vertical line test. You got g of x equals x squared plus 8x minus 24. So g of x represents some y value. And this means when x equals 6, what is the y value of this function? So we're going to plug 6, substitute 6 for x. And you will get 36 plus 48 minus 24, which is going to be 84 minus 24, and that's 60. So g of 6 is 60. This means when x equals 6, the y value will be 60. That's what it means. What if they ask you to find g of negative 4x? Now instead of x, you got to substitute negative 4x. So you're going to get 16x squared minus 32x minus 24. And that's far as you could go. And what if they want you to find g of 5c plus 4? So now instead of x, you got to plug in 5c plus 4. And you have to evaluate this. So this is the same thing as 5c plus 4 times 5c plus 4. Let's distribute the 8. And we have to FOIL this. So you get 25c squared, and you get 20c plus 20c, which is 40c plus 16. And we got to add up the like terms. So you get 80c. And what do you get here? You get 48 minus 24, which is 24. What will be the domain of this function? Now, domain means what are the x values that you could plug in here so that the function will exist. But notice, this is a fraction. So only time this function doesn't exist is when the denominator is 0. So let's first set the denominator equal to 0. Let's factor out x. So you get x equals 0, or x plus 7 is equal to 0. You get x equals negative 7. So notice this denominator is 0 when x equals 0 or x equals negative 7, which means it doesn't matter what x value we plug in here, as long as we don't put x equals 0 or x equals negative 7, then this function will exist. So domain will be, domain is all real numbers except x equals 0 or x equals negative 7. So again, as long as x is not equal to 0 or negative 7, then this function will exist. So domain is all real numbers except x equals 0 or x equals negative 7. What will be a domain of this function? G of t equals radical t minus 5. Well, remember, whenever you have a radical, whatever is inside the radical, it has to be greater than or equal to 0 in order to be a real number. So t minus 5 has to be greater than or equal to 0 in order for the number to exist. So what is it? T has to be greater than or equal to 5. So domain is all real numbers such that we say all real numbers that are greater than 5. So let's try. What happens when number is not greater than or equal to 5? Let's try 4. What's 4 minus 5? Negative 1. And what's radical negative 1? That's I, imaginary. So it doesn't exist. So in order for this function to exist, it has to be a real number that are greater than or equal to 5. So I have to say greater than or equal to 5. If you wanted to use the interval notation, you could just say domain is bracket 5 comma infinity. You could have just used that. We have a piecewise function here, and they want you to evaluate h of 67. Now notice, look at the domain. Where does 67, the x value, belong to? Well, it does not belong to the first piece. What about the second? Yes, 67 is between 66 and 68. So we have to use the second piece to evaluate h of 67. It will be 3 times 67 minus 132, which is going to be 201 minus 132, which is 69. What if they want you to evaluate h of 72? Let's look at the domain. Where does 72 belong? It belongs right here. 72 is greater than 68, so we have to use a third piece, which is going to be 2 times 72 minus 66, which is 144 minus 66, and it's going to be 78. So h of 72 is 78. Now let me ask you a question. What if they ask you to find h of 66? Which one would you use to evaluate this? Well, 66 belongs right here, because this says less than or equal to. So you got to use a second piece to evaluate h of 66. And you could do it on your own.